Hi, my name is Brian Toe, and this is my lab report for Lab 2, the motion of a falling object. Within the lab, we observed the motion of an object that falls downward in a straight line. The experiment measured the position over time for of this eraser falling in the experimental data, and then we constructed a computational model accounting for gravity only at first, and then a computational model accounting for gravity and drag. With Newton's second law, the first model predicted a position that accounted only for gravity being the unbalanced force, and so the F net was negative mg. Through the GlowScript code, I managed to create this model that tracked the position as the dry erase fell only due to gravity, and this was what was predicted. The second model predicted a position that accounted for both gravity and drag affecting the object's position over time, and so the F net was both negative mg and then minus bv squared, v squared being the drag force. As such, the position versus time graph is as shown due to the GlowScript model. Now we are able to compare these constructed models to the experimental data's model, and I found that the model that accounted for gravity and drag was closer to the experimental data, as it showed a terminal velocity in that the position versus time graph was starting to level off at the end in terms of slope. And this is shown here. The terminal velocity, as said, was it leveling off. And what if the object was thrown at first instead of just dropped? Well, the object would slow down to the same terminal velocity due to drag being proportional as it acts on the object, proportional to velocity as it acts on the object. And so both the velocity versus time graph of the dropped object and the thrown object in the GlowScript model were about the same in terms of velocity versus time. Overall, the lab taught a great deal about the motion of a dropped object.